In this video, you will learn how to identify the critical parts of and how to graph a horizontal hyperbola. Let's look at the diagram below. You'll notice that a hyperbola looks very similar to two parabolas, and so therefore it also has two vertices. These blue dots on the left and the right would be the vertices of a horizontal parabola. The vertices connect what we call the transverse axis. One thing I want to note is that the transverse axis does not have to be the longest axis. Next, let's look at the co-vertices. These are going to be up and down on a horizontal hyperbola. Now the co-vertices connect what we call the conjugate axis. Again, the conjugate axis does not have to be the shortest axis. Where the two axes intersect in the middle is again called our center. And these two dots inside the curve are still called focus, or foci for plural. Again, I would note that the foci are inside the curve, and this time they are going to be further away from the center than the vertices. Let's now look at some of the definitions. So what makes a hyperbola horizontal is where the x term or y term is. In this equation, because the x term is positive and therefore first, that's going to make the transverse axis horizontal. What's making it a hyperbola versus a circle or an ellipse is that we have a subtraction sign. So again, this is a horizontal hyperbola because the x term is positive, or first. Next, let's look at the center. Just like with your ellipses and your circles, the center is going to be HK. H coming from the x value term and K coming from the y value term. Notice again, because they're both subtraction, it will be the opposite. Now, a squared and b squared. A squared with an ellipse was always the largest term. Well, that's no longer the case. A squared is always going to be the first denominator, and it does not have to be the biggest. Now because we're horizontal, we want to take our center, HK, and move horizontally. So add and subtract a to the x value, or h. Again, I would recommend doing this with the graph, and so I would think of it as moving a units from the center the direction of the transverse axis. Next, the co-vertices, again, are going to come from b, but again, b squared will always be the second denominator, and it doesn't have to be the smallest anymore. We are going to move the opposite direction of the transverse axis, so we'll leave h alone and take k and add and subtract b. Again, if I'm doing this from the graph, I'm going to move b units the opposite direction. Now, C we had last time, and that also helped us figure out the length from the center to each focus. And that's going to be the same here. But we're now going to take the square root of a squared plus b squared. And that's mainly because if you look at your a and your b value, again, a squared does not have to be the largest. So if we tried subtracting it, we could end up taking the square root of a negative number. So here, to make sure that doesn't happen, we're going to always add a squared and b squared. Now as far as for your foci, that means, because again we're horizontal, we're going to take h and add and subtract c. Or I'm going to move c units from the center the direction of the transverse axis. Now that we have all of our critical parts identified, let's do a couple of examples. Again, the first thing I want to look at is if the transverse axis is going to be horizontal or vertical. In both these examples, A and B, x is the first term, and since the x-axis is horizontal, these will both be horizontal. Next, if I'm trying to figure out the center, this doesn't look exactly as we defined it above. So we could go ahead and rewrite this so that it does look just like above. What this is going to mean is that my center is going to be 0, 0, since there was nothing added or subtracted to the x and the y value. Now again, vertices, these come from a. And remember, a squared is always going to be the first number. And so if I take the square root of 25, I get a value of 5. So from 0, 0, if I move 5 units to the left and 5 units to the right, the two vertices of this hyperbola would be negative 5, 0 and positive 5, 0. Next, b is always going to be the denominator of the second term. And so for the co-vertices, I again want to move from my center the opposite direction of the transverse axis. So that's going to be up and down 3 units to 0, negative 3 and 0, 3. Now, just like before, I would highly recommend that before you figure out C in your foci, you go ahead and actually draw the hyperbola in. This is going to be a little bit different than how we did it before. Basically, rather than drawing an oval through these vertices and co-vertices, we want to make a box. Now this box is not part of our graph, and so we should be using dashed lines. But what this box does for you is it helps you see the asymptotes of the hyperbola. They're going to basically tell you how wide or how skinny to be drawing your hyperbola. And so to make those asymptotes, I'm taking my box and I'm connecting the corners with a diagonal line. You'll notice that these diagonal lines meet in the center. Next, since again this is a horizontal hyperbola, that means that these two dots on the left and the right are my vertices. And so I can draw my hyperbola, basically two parabolas, from these vertices. Your hyperbola should be getting very close to those two asymptotes we drew, but not crossing or touching them. Now that we have those drawn, I would go ahead and figure out C. Again, C is going to be found from taking the square root of a squared plus b squared, so 25 plus 9. And so here, 25 plus 9 is going to be 34, and I cannot simplify square root of 34, so I would leave it square root of 34. Next, if I actually wanted to graph those values, I would need to get my calculator out and figure out what square root of 34 is about. Square root of 34 is about a 5.8, so that means from my center I could go out 5.8 to the left and 5.8 to the right. Notice, those foci are inside my curves and they are further away, bigger than a units, left and right. Now again, if I take 0 and add and subtract square root 34, it doesn't change. So you can write it like that, or just the plus or minus square root 34, comma 0. In example B, I'd like to point out that again, a is always going to be the first denominator. And so even though 16 is a smaller value, a will be 4, and b, for my covertices, will be 7. Please now pause the video and complete example B. Please now check your answer for example B. Again, my center was 0, 0. The vertices, since a was only 4, the smaller value this time, I only went left and right 4 units from my center. Since b was 7, from my center I went up and down 7 units, the opposite direction of the transverse axis. To get c, I took the square root of a squared plus b squared, and I could not simplify it, and so I moved 8.1 units to the left and to the right from the center. And then to write my point, because I was moving horizontally, I took 0 and subtracted square root 65. At this point, please now share your information with your partner, and then both of you complete the examples on the next page.